My understanding is that this audience is the one that's filled with people that have working GPS systems and could actually find their way here. Is that a true statement? So, what I want to talk about is a dream that I had originally in the early 1980s, and then I continued to have dreams/illusions, and we'll see how that goes. So back in 1981, in August, there was a special issue of Byte magazine that was devoted to a programming language developed at Xerox Palo Alto Research Center called Smalltalk 80, which was actually released in 1982, and it was called Smalltalk 80. There were previous versions before that. Brad Cox worked for me at the time at ITT. He walked in with a copy of this magazine and said, you know, I think if I could pick up this new computer that we just had and take it home with me for a couple of weeks, I could build an object-oriented extension to C language. And I said, you have 2 weeks. And 2 weeks later, he came back and he'd built the first object-oriented extension to C language. And there was obviously no marketing department involved in that research lab. It was called Oopsie. And here's the cover of that magazine. That's quite a collector's item if you happen to have one of those sitting in your back closet somewhere. There's also artwork for that that's around. It was actually a 30-year anniversary of Smalltalk last June, which I went to out in Phoenix. Then in 1982, it turned out that I unknowingly became the first commercial user of Smalltalk 80. And by unknowingly, I mean I called up to the support number that was in this very high quality looking brochure that I was given as the first user of Smalltalk, and said, call this number and they'll have 24/7 support for you. And so I called up this number. There was a long pause, an even longer pause, and then finally they came back and said, I'm sorry, Evelyn is not in today. And that's what I learned about the support. It turned out that the real support that I had to try to figure out how to use this new language and development environment was the Byte magazine article. That was the whole issue, actually. So I spent a considerable amount of time trying to figure out how things worked with the working software and the Byte magazine sitting on my desk. Then in 1983, Brad and I spun out a company which was the first object-oriented products company. And interestingly enough, it was founded in the fire hose factory where the vulcanizing process for rubber was invented. And it's also a half mile from the school that has been far too much in the news recently, right down the road from that school. Objective-C was actually shipped in November of 1983, the first commercial object-oriented programming language at that time. Here's a picture of that mill. The other thing they didn't tell us about this mill when we moved in was that it was the coldest spot in the state of Connecticut for many, many years, because it was sitting in this nice river valley that was protected from the sunlight about 8 hours of the day. But it was a gorgeous place. So Objective-C was designed as a hybrid language, and the whole idea, and a very important idea, was that absolutely nothing in C language would be taken away from you. It was a purely additive addition to the language. It was really a pre-compiler, so that you submitted your Objective-C program, or you ran your Objective-C program through the pre-compiler, and that generated C. And that was very important that we didn't make that change. The whole idea was, inside the brackets, it's an object-oriented programming language, and outside the brackets, it's the C language that you know and love, or know and don't love. We also had a basic class library as a part of that package, and we generated the term software IC, and therefore the class libraries that we sold were called IC packs, 101, 201, etc. The early users were really kind of the who's who in the business at that time: Hewlett-Packard, IBM, Apple, US West, Siemens, Philips, and many, many others. was quite interesting. The collection of users and the things that happened. There's some funny stories about any startup company. One of my favorites is actually from a U.S. West. No, I'm sorry, it was not. It was another company, and I won't use the name. Another company in Colorado called up and said, "Your goddamn compiler doesn't work." So what do you mean? And he said, "Well, it doesn't handle enough classes enough methods for our classes." And I said, "Oh, really? How many do you have?" And he said, "Well, let me count them." And said 34,563. I said, "Well, it actually supports 32,000. So if you could trim down your one class from 34,000 and change methods to 32,000 methods, it would all work." And I said, "Oh, by the way, what is the name of this class that has 35,000 methods in it?" And he said, "It's called Graphics Library." And I said, "The other thing I think you need to do is to go get a book on object-oriented design and learn a little bit about how you might break this up into something smaller. I'm not sure that's really a defect in the compiler." It was a very competitive space in the mid-'80s as far as programming languages. Everybody was trying to figure out what the right object-oriented programming language could be and should be. Here is a list of them. There were others, and it turned out that this was such a competitive space that we got together and decided that we'd have a little competition. And so we had this from a friend of mine who was fascinated with this little game called Greed. So we wrote down the specifications for this game and sent it to all the programming language compiler companies and said, "Develop this application, show up at this object-oriented conference, and we'll compare notes, see which one runs the fastest, which one's the easiest to modify," those kinds of things. And so we had quite an active competition. All of the major purveyors brought their best code, they thought, and Hewlett-Packard gave a little award to the winner of that. And this whole conference called OOPSLA actually came about in a very interesting way. It happened on an airplane when my sales guy and I were flying to the West Coast, and we were talking about things that needed to happen in this emerging industry. And we had the idea that what we really need to do is to create a conference. And it occurred to us about over Nebraska that we were going to be meeting with everybody that week that needed to agree to start this conference. So it turned out that on Friday of that week, we got everybody together in a restaurant in Palo Alto, and a year later, the OOPSLA conference was created. It actually turned out to be the largest and most successful IEEE conference in its first year in the IEEE history. There's a nice little artifact that I have on my wall, which is I have the napkin from that lunch. Here's the set of companies, here's the set of people, and people and talks that we might try to organize, and it turned out that virtually everybody on that list actually ended up at the conference, and most of them in fact gave presentations. So it turns out that OOPSLA actually has been a very fertile ground for innovation and been very important for people to get together and talk about various technologies and ways to make improvements. Here's a recently developed list of technologies that spun out of interactions that were all initiated at the OOPSLA conference. A reasonably important list of techniques and tools. So recent newsflash, Objective-C is now the third most used programming language on the planet. And that's quite interesting. It follows only C and Java, if you believe this particular way of counting that that usage, which I of course do believe in. If I imagine everyone here is actually carrying a smartphone of some variety. I probably even have one hiding down in here someplace. These little devices. There's a way to think about these little devices that we don't often think about, which is that that if you go back and compare the performance of a modern day iPhone, it's about the same as the performance of a Cray 1 supercomputer. And Cray 1 supercomputers, had buildings built for them. It also has a higher resolution screen than existed back when Cray 1s existed, and it's connected by way of higher speed, both wired and wireless networks than actually existed at that time. And these phones also know where they are within some precision. And so there's some really powerful devices that we have in our pockets. And we've got lots of programmers that know how to write programs and develop websites based upon these little devices that we have in our pocket. These programmers, like many people in this audience, are very smart, very energetic, take the web for granted, haven't seen, are unfamiliar with the world back when computer programming is done with things that look like this. But it turns out that many people that are involved in doing modern day applications have never actually written enterprise applications, never written applications that involve hundreds of thousands of users, that involve users from all around the world or all around the country. And so this distinction between building an app and building an enterprise app is an important one, and there's a big distinction between that. And with all these powerful tools that we now have, and given that we're almost inside the Beltway here, we're a little bit outside, it turns out that there's a recent report from the US government that says that only 16% of the enterprise software applications that are started in the federal government are actually completed. And then of the 16% that are actually completed, it turns out they only deliver 61% of the functionality that was originally specified. It's actually a pretty lousy record. And we don't have many people that are actually trained in doing mobile enterprise application development that know how to lead teams of developers that might be in the hundreds or even thousands of people. And we don't have many people that know how to build really high quality applications that involve life or death decisions that might be involved in either medical applications or avionics applications or financial applications that are really, really important. And there are even fewer people that have the experience of building significant enterprise mobile applications on time, on spec, and within budget. So, is there anyone in this room that's surprised that healthcare.gov didn't work? And I have a nice image for you, and I hope somebody here that's involved in animation is going to send me a little email with a present in it, and it's going to do the following. Did you realize that if you just printed out the source code for healthcare.gov and stacked it up alongside the Washington Monument, that it would only be 9 times higher than the Washington Monument? That's a really big stack of paper. And can you imagine a team of developers saying, we're going to get this fully tested in 2 weeks' time? I mean, what were they smoking? So, what I would suggest is it's really important that we figure out how to design, build, manage, test, document, and deploy enterprise applications, mobile enterprise applications, in fact. So I can imagine the day, remember this all started off with a dream in the early 80s, when all of this, everybody in this room are going to be building mobile enterprise applications on time, on spec, and on budget. And it seems to me that now that we've figured out how to make a safe transportation system with airplanes that contain 500 or 600 people, where in the United States recently we had 2 full years in which we didn't have a single fatality in a commercial airliner, in spite of the fact there are 50,000 takeoff and landings per day in just this country. So it seems to me that we're at a point where there's entirely new things that we need to learn, but there's an enormous opportunity to to replace all the antiquated legacy systems that we are so polite and sit and watch people try to use at things like rental car agencies or airline counters if you happen to travel. I got finished ahead of time because when you sit and talk about being on time, on schedule, and on budget, it's kind of a better idea if you actually get done on time. So open for questions. I'll do my best.
So you talked about the history of programming languages. What about the future? Where do you see programming languages heading?
Well, you know, it's interesting. We haven't had a collection of new languages recently, nor have we had a collection of new operating systems, for example. You know, a few maybe, but small number. I think we're ripe for some completely new innovations in this department. I'm not aware of ones that you can point to and say, I believe that's going to be the next, you know, language to be in the top 3 or top 5 or top 10 of the languages. Maybe others know of something that I don't.
How did Objective-C get adopted by Apple?
Because of the reverse takeover by Next. Next, the full story, well, not the full story, but part of the story is that we were at a trade show in Southern California the week that Next actually was announced and they opened the doors. And one of the engineers from Next was at that trade show and came into our booth and said, you know, I think you guys need to come to Palo Alto and talk to Steve Jobs, and this is probably just exactly what we need. So I rearranged my flight schedule and went back by Palo Alto and you know, had a presentation as they were moving the furniture into the office. Next decided to use Objective-C as their system programming language. Then when Apple acquired Next, but really what happened is that Next acquired Apple because all the people in positions of responsibility were previously at Next in short order. Then they had to make a decision between the old operating system and development tools versus the ones provided by Next. And since Steve Jobs was making the decision, guess which one he chose? That's how it came about.
As a language designer, what would you like to see that would improve programmer productivity? Considering all the history and what's going on.
Well, you know, I come at this world from an extremely unusual direction. I did a PhD in cognitive psychology in the mid-1970s, studying the characteristics of successful programmers. And in the process of that, I got involved in looking at what are the characteristics of programming languages that make them easier to modify and change and to debug and so forth. And readability is absolutely crucial. The other thing is succinctness. You know, I like languages like Smalltalk, for example, which is a very simple, succinct language, not very efficient. To me, you know, if I ran the universe, I would make Smalltalk the first programming language for developers, because I think it teaches you some fundamental concepts that are hard to grasp. I've done, back in the day, Brad Cox and I used to do a lot of training classes, and I remember one group of assembly language, we had 50 assembly language programmers for 3 days to try to teach them Objective-C. And boy, was that hard. Because every time we would say something, they would say, well, show me how the code is generated and how does that translate into, you know, to the assembly language for the computer. I think, you know, the sequence of which, it's important to learn multiple languages, but the sequence of which you learn the languages is actually very important. So brevity is a good idea, readability is really important, ability to cope with, you know, complex problems. There probably need to be specialized languages for different kinds of applications. If you're doing, you know, complex engineering modeling, you have a different set of constraints than a medical application, for example. There was another question back here, a hand.
Yeah, so you talked about the difficulties with building enterprise applications and, you know, on time, on spec, on budget, which is absolutely spot on, but I'm curious what your thoughts are with using like mobile backend as a service or platform as a service to sort of facilitate abstraction that typical dealing with building some web mobile apps.
Yeah, well, you know, it was mentioned earlier that, you know, the name of our company is Shoulders, and we jokingly say that Isaac Newton had the forethought to name our company. He's quoted, he really stole the quote, but he's quoted as saying that, you know, he was asked how did he accomplish so much in his life, and the answer was because he was standing on the shoulders of giants. Similarly, we believe that, you know, there's no reason ever to start from scratch in the modern day. There's lots of, an enormous amount of capability, lots of open source software. Be careful about what you actually own. I've worked with companies that have had the problem of they got some software that was free over the internet, didn't bother to read the full license agreement, and discovered that it was free as long as you had less than 5 users. It turned out that this particular application had 225,000 users, and there was a really big bill that was due as a result. They thought it was free, but they hadn't actually read the full terms and conditions. So it's important to do that, actually.
With the performance of modern smartphones and the like, what are your thoughts on an alternative way of, instead of developing thick client applications, using, say, Objective-C for an iOS, versus using the thin client, JavaScript, HTML, CSS, and then bundling it essentially with the phone gap, especially for enterprise applications that are not necessarily high performant like a game type application?
You know, this idea has been around for 40 years. I believe that there was a thing called a Blit terminal in AT&T in the late 70s that really had this notion. And a friend of mine in Connecticut has been working on something similar to this, you know, for some time. I think there's certainly many applications for which that's absolutely the right is the right thing to be thinking about. Is, you know, very thin client applications that you know, rely on back-end services. I don't know if I answered your question.
Well, actually, I was kind of focusing more on when you bundle this stuff off with phone gap, you essentially have created a thick client application, but you use a different set of tools.
Right.
HTML, CSS, JavaScript,
Right, and you know, and one of the challenges, we worked with a financial services company that, you know, they had the problem of 80,000 users of their software, and they had something like 25 different versions of that software that they were trying to maintain, and it was just a, you know, complete nightmare, and that's something you have to be very careful about. 2 minutes. One more question.
Has Objective-C evolved over years, or has it stayed the same?
It has certainly evolved, but not in any giant fundamental way would be the way I would describe it. Thankfully, it's evolved. Otherwise, it would die, of course. Well, thank you very much. I hope your GPS system works on the way home. Take care.